Hi everyone. So today's video is going to be focused a lot more on probability. So something that's coming up a lot more in some of those year 12 trial papers and HSC questions is actually a lot of year 11 conditional probability and the probability notation questions, which can be a little bit tricky. And I found a lot of students struggling a little bit more with those ones as they continue to pop up in some of those trial papers that are being done for revision. So what we need to understand here, and we need to utilize some of the formulas that are in your formula sheet. So your formula sheet does give you some of your conditional probability formulas and then your independent formulas as well. So always important to remember the difference between independent events and mutually exclusive events, which what we will focus on with these two examples here and how we can kind of bring in some of our notation and utilizing some Venn diagrams here to help us answer a variety of different questions. So once you kind of understand these core concepts of what probability questions can ask, you'll be able to answer a large variety of questions to do with those. So let's have a look first by going through these two examples here. So the first one that I have here, we have for events A and B, the probability that A intersection B is equal to P. We're told also that the probability that A complement the intersection of B is equal to P minus 1 on 8. And the probability that A intersection B complement is 3P on 5. Now, we're also told that A and B are independent. So what independent variable means is that the probability of one the probability of one event does not necessarily impact the probability of another. So yes, they can have some shared aspects in their intersection in their Venn diagram, and intersection does exist, but the probability of one does not necessarily impact the probability of another. So for example, the impact of flipping a coin and then rolling a dice, those are two independent events and they don't actually impact the probability. So my probability of getting a 6 on my dice is not impacted on whether beforehand I flipped my coin and got a heads. So that's the meaning of independent events. In your formula sheet, you get this formula as well. So when we have independent events, A intersection B, so what's in the intersection part of my diagram, is going to equal to the probability of A times by my probability of B. So whenever you see independent on your trial paper or your HSC questions, straight away write down that formula. That's going to help you a lot there. Now, we're also told that the probability of A and B is actually going to be P. We know that that A complement and B is equal to P minus 1 on A, and A intersection B complement is 3P on 5. So these notations look a little bit complex when we haven't really had much time to look at them. But what we'll do now is we'll kind of split this up and illustrate it in a Venn diagram. So my two events here are going to be A and B. We know that the intersection here, A and B, is going to be P, so that probability there. Now, what this means, A complement and B. So what's in A and B, but not in A? So what's in B and not in A? So what we're going to be looking at, what's in B and not in A, would be this part here. So what's in B and not in A is going to be P minus 1 on 8. Alternatively, we now have what's going to be the value of P, A, and not in B. So what's the probability of what's in A and not in B is going to be this one here. So that's going to be 3P on 5. Okay. Now, if I want to find the probability of A, that would be this circle here. So the probability of A is going to be the probability of A not including B. So 3P on 5 plus my intersection. My probability of B is going to be by P minus 1 on 8, and then once again plus my P, so making sure that we're adding in that intersection. So we can simplify that a little bit more. So this becomes 8P on 5, and this becomes, just collecting those two P's as like terms, 2P minus 1 on 8. All right, what we can do now is use our independent events formula at the top here. So we have the probability of A and B, which we said was P, is going to equal to 8P on 5 times 2P minus 1 on 8. So notice I'm putting these in brackets because my second term has two terms I need to include. So I will be using a little bit of FOIL here. Okay, so expanding that one out, so using my FOIL technique like I said, we're going to have P is equal to 8P on 5 divided by 2, times by 2, 8 on 5 times by 2, which is 16P squared on 5, because I've got 2P terms now. Now I've got 8 on 5P times by negative 1 on 8, which gives me negative P on 5. Okay, simplifying that across. So adding times in all sides by 5 now, so that I get rid of my denominators. Working up here, I now get 5P is equal to 16P squared minus P. Once again, here I've got a quadratic going, so I've got this is P. So making everything on the same side, I now get 16P squared minus 6P is equal to 0. I can then factorize out a common factor. So I have 2P as my highest common factor here. And inside my brackets, I have 8P minus 3, which is equal to 0. So therefore, I get either 2P is equal to 0 and therefore P is equal to 0. Or I get 8P is equal to 3 and P is equal to 3 on 8. So therefore, P is equal to 3 on 8 is my only value here, because I have my p-value cannot equal to 0. So that's super important there. Your p-value can't equal to 0 because we know that they're independent events and that their intersection does exist. So if there was a probability of 0 in your intersection, that just wouldn't exist. So it has to be greater than 0 here. So therefore, p is going to equal to 3 on 8, which is option C in my multiple choice. So that's how we can use independent events to answer these probability notation questions. The next example that we're going to look at is when events are mutually exclusive. So what mutually exclusive events is that they have no overlapping properties. So what that means, if I was to illustrate it in a Venn diagram, is I have my probability of A over here, and I have my probability of B over here. They have no overlapping probabilities. There's no intersection between them. So if you want to take the dice and the coin example again, like for example, when I roll a coin and when I roll a dice, my probabilities are going to be from 1 to 6. That's my sample space. So I can't roll a dice and get a heads. So therefore, those two are separate in that way. Okay, so we're told that my probability of A here, if I want to represent this in my diagram, is going to be P, and my probability of B is going to be Q. And we want to find the probability of that it's not in A and not in B. So that's what this means. A complement intersection B complement. What's not in A and not in B. So if this is my Venn diagram and I'm looking for what's not in A and not in B, and there's no intersection between them because we know that they're mutually exclusive, I'm actually going to be looking at all this outside space here. So what's not in A and not in B. So therefore, we know that all probabilities here have to equal to 1. So I have 1 minus P minus Q. So if I have a look at some of my options there, simplifying that, I have 1 minus P plus Q, which is what is option given to me in option C. So just rearranging my answer a little bit at the end there just to fit in what's with my multiple choice. But that's all we had to do there. So mutually exclusive, think about two separate Venn diagrams, but independent events, they do have an intersection, but the probability of one just doesn't necessarily impact the probability of another. And we have to use that notation there. So definitely number one tip I would give is draw out what's happening in those Venn diagrams. You might have noticed that I repeated the probability notation in words quite a bit there. I find that really helps kind of understand what the question's asking as well, because it can be a little bit difficult when you're looking just at the notation. But other than that, having that knowledge now, hopefully it makes it a lot more easy to go through these probability questions.